Hello, everyone. Hey, everyone. My name is Dmitry. I'm working at lightsource.ai, but it doesn't matter. We're doing it matters. Like we're doing Rust-based supply chain platform. We have fancy animations, and if you are a talented Rust engineer, you know where to find me if you want to have a nice job, right? But today I'm gonna talk about my different passion a little bit. It's videos. It's actually all the media files. I love the media programming. Yes, sorry about that. I will try to not do that. But in fact, I love media programming. I love everything related to the media files and especially videos, which are dang complicated. But I started 3 years ago, I started my pet project, kind of my side project. It's a giant framework written in Rust that renders the video files. So basically, you can make binary that renders a video file. And I'm working on that for 3 years. And in fact, it's ready, kind of. It's in closed beta state. You can try it right now. And all of the code samples from this talk will be actually somewhere from a code base. Kind of simply, maybe simplified a bit, but in fact, yes. And today I'm going to talk about the Wasm video preview from this framework. So basically, you render video, and I'm going to talk about dev tools that I built for this framework that allows you to, in real time, see what the video is generated. So basically, you can see that it is just like playing the video. And basically, it is in a browser, it's in a Wasm, and like on the right side, you can see the actual video. On the left side, you can see audio files. And all of the problems I had during the building this stuff is processing and working with media files. Because rendering is actually like okay, because we are rendering SVG. It's SVG-based framework. Browsers are good in rendering SVGs. So we're going to talk about the media files on the left side and how I made to work with them overall. I think it will be interesting. So what is the most important part of the video? How do you think so? What is the most part? Okay, let me ask a question. Yeah, when last time you were watching silent movies? In 1920s? So yeah, like in fact, audio is the most important part of the video. Basically, you are not watching videos silently. That is not useful, right? So let's start on the most important, the most complicated part, one of the most complicated part. So audio files. What is audio file? Let me do a quick overview. So basically, audio, sound is a vibration, right? And microphones, like this one, can record vibration and time per second. It's 44,100 time per second. And this one recording called sample, and basically all of what is audio file is basically a set of samples, right? It's a vector of f32. It doesn't matter. It could be int16, it could be an arithmetic, but in fact, like it's just a simple vector of whatever time samples were recorded. And it's nice, but it's encoded, right? It's a giant audio file. It's basically binary, right? It's just a file that you need to somehow work with. And when I started, and like when I see how people are working with media files in Rust, they're basically trying to ChatGPT how to decode the audio files. Okay, here is what encoders that we have. Okay, let's use Wasm encoder that is the same one. I use mini-mp3 on backend. Let's use mini-mp3 Wasm built into the browser and then just work it. And that's fine, but please don't do that. And I understand that this is weird that I'm saying on a Wasm conference, I'm saying do not use Wasm at the first my statement, but in fact, like browsers are kind of good in working with media files. So here's a Rust sample that is rendering the decoding audio files. You may like it, you may not like it, but it's the most efficient way to now get the vector of f32 in WebAssembly. And it just works, and it's kind of like even beautiful, you know, like you just, yes, it has its dynamic index, but you know, why not? Like it has arrays, it has everything, and then you have just like here you can have a channel data, which is basically everything you need to. Right? And now when you have this vector of f32s, you can do whatever you want to. Like for instance, here is the simple code samples that I wrote very quickly to just showcase how it works. Like how many? 5 lines of code, right? But you can do something really beautiful with that. Something like, is it cool, right?
This is even cooler.
And this is basically what's this sound, these 5 lines of code are done with audio file from the previous code. And in fact, it's just like a very simple example. You just set in like the delay in time and you are setting the room size kind of, and it just works. And it's nice. You can get it back to the JavaScript world, or you can play it through the audio context right here through the JavaScript bridges. And you know, like you can go more over that. Once you have the samples, you can go to the whole digital audio signal processing functionality. You can do whatever you want to. Want to build a VST plugin? It would be a VST plugin, but you can, and you can actually like do whatever you want to, like be a DJ, do something like that. There is a crate in Rust called DASP that allows that is built into Wasm perfectly and allows to have primitives to work with audio. And once you get into that, it's really fun when you have pure audio data and you can change it somehow using your code. But in fframes, we do that. And moreover, what we do is we are mixing the files in Rust, basically, and in Wasm as well for the previewer. So here is a general video timeline in fframes. There is a bunch of audio files. They're all different sized, all different volumed. You need to process every of them. You need to align them to the gain them as the user wants to, and mix into one thing. And I think that I don't have a code sample. I somehow missed that likely. Yes, I did. But in fact, it's nothing more different than just taking a bunch of vectors, somehow merge them, and then align into one. Basically, you just fold into the vector of samples and merging them, like aligning using specific algorithm. But because the vector of F32, the volume is 0 is no volume, 1 is volume, you just like align in together the F32s. But that's not even what's really fun. Here's what's fun. And here's
Hey everyone on Wasm.io. I hope you're enjoying the talk so far, and let's just all admit that this animation looks gorgeous. Okay, now passing my voice back to my future me.
So thanks, Dmitry, but in fact, this is just rendered video from fframes, and if you don't believe that this works in Wasm in real time, it does. So you can just scroll your timeline, it just works perfectly fine. You can analyze, you can visualize your video, and it just works cool, because you can process the data. And this is how it works. It works using Fourier transform. You can do that very efficient in browser. You can use one of the Rust crates. Here I'm using micro FFT because it's no STD, and at the same time it has bitrefs, which is algorithmic optimization for the FFT, which makes it really fast, and especially in Wasm. And basically what you have here, you just asking for 16 samples for 16 frequencies from the samples array, and then you, because it's getting back you the complex numbers, you are normalizing them to get amplitudes, and then you just render everything you want to. Like this fancy waves animation, it's like, yeah, it has more code, I agree, but you can drag some bars, right? And it just works as well. And that's really nice, right? You can do that. And all of the equalization, all of the modern like codecs are also based on Fourier transform. You can just use and you can process audio whatever you want to. Like I don't understand why nobody built Vinamp in browser yet. I don't really understand that. I miss it. But hold on. Okay, I understand. I see some eyesights on me, like very. This doesn't sound right. I feel like it doesn't sound right. This looks good, right? So basically we're doing some weird unchecked into, but how is it possible that WebAssembly gives us a owned VAC F32 in Rust? It doesn't sound right. So let's break it down. Just check how we'll just like, there's a function that is called in the WebAssembly text format, the VAT, right? So here's what I found from the build binary. And I can see that there is an import from the vasitest bggs that is calling the weird function channel data. And then I'm getting a pointer. Wow, I was so excited. No, I don't. It does the copy of the whole file. And this is kind of what you can't avoid with current modern browser, JavaScript, and WebAssembly, unfortunately. So basically here, the get float 32 memory sat is where the copy happens. And this is needed because we need to own the memory, and we can own the memory only in the other direction. So I thought that this is bad, and this is really bad, because here's the Bevy. If you don't know, Bevy is a 2D engine, WebGL based in Rust in Wasm, that allows you to build images. And here's an example for audio files. Here they load the sounds windless slope OGG, and you can see the problem. Here highlighted in a waterfall example, you can see how much time it takes to get from downloading the Wasm example to actually start downloading the slopes and then playing them. It takes a lot of time, because it's kind of like you want to manage your resources from WebAssembly, you want to download them quickly, and you don't want to copy them. So how to deal with that? In fact, I created a new strategy to doing that. And it's not because I'm that smart, but because I have a very specific, very weird use case where I'm doing the dev tool for the browser, right? So I know how it's gonna compile. So I'm just gonna cover a bit of how it is doing and why it is becoming really nice. So what I saw that, so basically, if we're talking about WebAssembly, there's a data section like in any assembler that inlines global files. So let's just inline all of our data in it. So here is already working example why it's string. Don't ask me why this is a string. This is a string because Rust encodes static bytes as strings because it's easy for, for Rust for some reason. But you can use the bytes section if you just work with a pure WebAssembly, and it just works. How? A little bit of unsafety. So here is an idea. In fframes, when you have a known media file that is not dynamic, that is not 1 hour podcast long, we just take your audio file, in a compile time, we decode it using libav directly from the compiler in Rust, then get in the samples from the compiler, align them with bytes, and inline. So all of this align literal and all of this fframes aligns too is basically align as alternative in Rust from C, right? So you just align the F32 as bytes to make it work, right? To not seek faulting. And then you just like in a runtime, the string that happens in runtime, you just basically casting the slice back, and it just works. And then in runtime, you don't have all of these things because yes, it's a bit of unsafe, but all of the decoders, I wrote like libav decoders in for fframes, and it's just like all of this unsafety, weird unsafety, and you can just avoid that, and you can have all of the audio file directly in the audio file in your binary. So here is how it looked before. So here I just had 5 audio file that works, that needed right now, that gonna play right now, and you can see that it's kind of like, I don't know, like here, like it's reloading the files, and it's reloading, it's doing this reload on every keystroke, on every save, and it's kind of slow. And here's after. Just take a look on this like arrow, right? You can see that the browser even caches the internal view. So basically, my fully featured video editor, video previewer, is now faster than modern SPAs because it doesn't have waterfalls. And if you think that the WebAssembly is weird in terms of like it's weird to encode your audio encode your media inside the binaries, it's not, because the WebAssembly sections are perfectly aligned, and it like first parsing the code and instructions is harder than parsing memory, because parsing memory is just a giant block of memory that size it, and you just read it whole, and the WebAssembly don't need to parse it unless it needed. So basically, encoding a giant encoder, like shipping the giant decoder into the Wasm, is much slower than decode small audio file. And it also gives us a neat public API because you can use the macro to create your perfectly fine struct, and then you have compile time guarantees that the specific media is available. So here's image, but it doesn't really matter because you just do the same with audio. And you always know that your binary always contains the audio file, and if you're building like things like that is required to have audio files, like for example, a game that have a sound, just make sure that you are not overwhelm your code with unneeded like decoders, especially like in Wasm, and you avoid copies because you can do that. And if we take a look on this example, you can see that this is a public API for frames. You can write SVGR, which is a macro for SVG, and you have an image. And you know what's the big problem of SVG? It's basically images, right? So everyone hates SVGs like that, but fun fact, in fframes, SVGs are literally like that. It looks like that. And apparently, it's the fastest way to work with SVGs in Wasm in presenting, and like for us specifically, to deliver that into the browser-based previewer, because there are 2 ways of working with images in browser, in WebAssembly. The first one is Canvas. If we're taking a look at one of the most popular, it's the most popular Wasm-based image processing library called Photon, and how they are processing library, they're doing the same thing. They're calling 8 JavaScript, this JavaScript back functions, doing 2 data copies to get the pixels into JavaScript, into the Rust world, and then they just do all of the processing, which is actually, like, I don't want really to include it because it's really simple, because image is basically, right, is a set of pixels, sRGB. You have 1 byte for color, you have 4 bytes for pixel, and you just process it. It's not a problem, right? But the library is pretty nice because they have situations, all this stuff. Or you can, for sure, you can statically align inline, or you can compile time inline the images which are required for you right now. And it also works fine. You can do that very quickly, and you can render that very fast. Because, okay, so there's a bit of processing library. So it's a WebAssembly Photon Wasm is basically a Rust library that you can use in Wasm that can do image, like all of the changes. So you can just use it as it does, but has all of the primitives, and you can build your Photoshop or whatever based on that. But in fact, what it does allow us, so when we have an inline-based images and when we store images as base64s, we can first render them like indefinitely, because browser has an in-memory cache for images, and even if you're rendering them onto the canvas, you just like have inline optimization for everything. You don't have the waterfalls bottlenecks when you download an images. And here's a canvas that also, like, giant canvas with a lot of previews. All of this are individual frames. All of this are running Fourier transform to display audio analyzation. All of this displaying images, and everything works just like very fast, thanks to the dynamic audio preview. But I'm just not saying that this is bad. Just like, I'm not saying that downloading images from the fetch is bad. You still need that because obviously most of the time images are somewhere, and it's not that slow. But when you, I'm very sorry for that. So when you are getting images compiled, it's just like next level. So basically here is the data structure that works in not Wasm. We're just having all of the pixels inlined for the image data. And in Wasm, we're always having base64, and it just works because browsers are damn good in base64 and rendering images. But so what to do with SVGs? SVGs is also images. We have public API based on SVG, and SVG is kind of scary, you know? Like, SVGs have very concise, very neat, very declarative API, just like on this website. Okay, I see you are slipping off your code break. So basically, no, it's not. Like, right? So SVG is kind of weird sometimes. You don't want to understand these things. But at the same time, SVGs, do not be scared of SVGs. SVGs are a very declarative XML-based format that allows you to do something like that. Very declarative declaration of graphics for a certain frame. Like here, you just have a rectangle for background, you just have a text, you just have everything here, you just inline it, right? And that's nice, but you know, what we can do with SVG more. We need to render it somehow. And again, we can do the compile time optimization and render SVG from the Rust. So basically what we do, we are taking the SVG and parsing it in AST in runtime, and then inlining the AST basically into your Wasm binary, which is good until the certain size of SVG. Sometimes it's just faster than to de-optimize back to the string, but in fact you just can parse SVG in compile time, inline it into the Rust, and then just render it using React or your favorite tool without like parsing. So if you are getting your SVG from Wasm and you need to render it, you can just inline it directly and then render it through React. So you have benefits of virtual DOM. You can use whatever virtual DOM you use. You have like optimizations. So the video, when it changes, it doesn't change the whole SVG is not changing, just only certain parameters that are changing are like literally updated in the DOM, and at the same time you have a very neat representation of SVGs in your code and in your Wasm. And you have no JavaScript thanks to. But what is the biggest problem of SVG? According to Stack Overflow, it's one of the most liked questions about SVG in Stack Overflow. It's text wrapping. So basically the question, can I wrap text in JavaScript in SVG? No, if you are not No, because it's not a part of SVG spec, and you can use it only in browser using foreign object. So let's fix that using fonts. Fonts is the next media file format that I'm gonna cover today. And what is font? Font is always just a binary format that is not encoded. It's just a pure binary file that is already have all of the information that you might need to resolve the actual glyphs, to resolve all the information. And fonts contains of glyphs and specific information about this certain glyph. You have some sizes, you have some everything. It doesn't really matter right now. And the shape of the glyph itself. And what you can do that? You can do a nice things with this. So for example, here is, I just won't spend more time saying that this byte can come from the fetch, or you can compile time inline it. And the fonts actually have much more sense to inline and compile time, especially if you are rendering them like that. You can have, for example, if you ship them on the microcontroller, you can just inline your font, a bitmap font, and then just use it directly. But here's the thing. You just have a font that you can parse. And fun fact, this TTF parser created in Rust does not allocate. So basically, it just sets the pointers to the specific parts of the binary. And then you can just look it up for a specific table, for a specific binary position, and get a direct pointer to the name that is set inside of the binary file itself. The fun fact, neither browser nor Figma can do that. Because in Figma, one of the biggest problems is the fonts management, right? Because Figma does not allow you to drag a font. The most powerful, the most popular WebAssembly application does not allow you to just get a font, download it. They require you to install some kind of font manager on your computer, install desktop application. And that's so weird because like you can literally do that in 2 seconds. And if you're gonna build the Figma killer, just you know where to start. And here is something more interesting. We can resolve the char widths, right? What does it mean? You can get information about the certain character, like, right, the symbol. Okay, I found the bug here, symbol char, doesn't matter. So you're just getting the certain char and resolve the size in the font size as you want to. So the units, so the fonts are storage size in EM, which is a specific size directly for this font, which you can then scale as you need to. And this like 5 lines of code, and you have direct character size from the font file, just like in browser do. And now you solve the problem with text layouting, because you can wrap text in SVG, because you know the sizes of text, of characters, you know the sizes of words, and you can solve the problem of rendering text in SVG. So basically, here's a funny mail that I get from my closed beta project that they were looking for a way to wrap text in JavaScript, and they heard that somehow somewhere there is a function that wraps text in SVG, and actually it was in my project, so I gave them beta access, and they just used it to build real text wrapping in SVG, which is not possible without like knowing fonts. And it's really simple. But we can go much more beyond of that. So let's do something really, really interesting. We have, for example, we can do the same thing. We can find the glyph ID. We can find information about certain glyph, and then we can use outline glyph. It's also part of this crate. And what we'll get, can you guess what we will get in this builder after the execution? Surprise, SVG. Everything is SVG, and basically you can just take SVG out of the builder, out of results font, right from the browser, and then you can just render it into the canvas. And this is actually one of the SaaS that I found today. It's just like the people are paying for that, and you can build them like in 2 functions in WebAssembly, and then just render it to the canvas. Maybe just add some lines, like so it's shaped, and you can then repack your fonts back. And this is like really nice, and you can do that very fast, and you can do it right now. And unfortunately, nobody is doing that for some reason. Okay, so I feel that we don't have much more time anymore, but I'm gonna cover a bit about the videos, which are also media files. And to be honest, everything is bad with videos. So videos are a collection of the audios and images. And in order to get them, please don't use Wasm. It's slow, right? It's slow. Endless times I tried to build certain things using mscripting from libav into the Wasm and use it together with the Rust binary, and unfortunately, it just doesn't work nice. There is a proposal called Web Codex that just works much better, but unfortunately, it's flagged everywhere, and unfortunately, it's sick faults. So basically, currently, videos are in fframes video editor is supported really weirdly because we have a very specific scenario, but you can still do that using good old canvases and good old manipulation. Unfortunately, it's just like I once spent like I have giant stack of slides next. So yeah, let me just skip it. Yeah, and yeah, we are running out of time, I think, right? Yeah, and yeah, so basically media is doable in Wasm. In Wasm, you can very seamlessly, very like in 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 the very uh, you know correct manner work with the media files. You can even avoid copying of the memory of the files to the WebAssembly, and you can do literally a lot of interesting stuff that people are not doing right now. So you have a power to do that because browser-based WebAssembly is just like, it's just a treasure that you can use to do something that were not possible like literally yesterday. And just don't be afraid of media files. Don't be afraid of compiling media files, playing around with that. It's really fun and it's really doable. So, and it can be really fast. Thank you. Yeah, so here is fframes Studio, where you can find the invitation to the beta of the fframes framework, and you can find all of the code snippets and all of the things I've been talking about there. And thanks for your attention. Nice. Any questions? Yeah, sure.
There is a lot of rendering process we are doing expecting canvas, and so they are done on the browser. Is it possible to execute them also on the server so we can generate the
Sorry, one minute. On the server side, from a canvas?
no to instead of targeting canvas, targeting like file generation?
Yeah, you can, but like, I mean, the canvas are not that slow, right? So when you render an image on a canvas, it's very fast in the browser. You can just render canvas, and it will be much faster than doing that through server side, for sure. Like, so you shouldn't do that probably through server side. I tried to a little bit, but like, in fact, canvas are pretty fast. The problem that WebAssembly right now requires the whole data copying, and if you downloaded the whole byte from the server, it's still doing much bigger overhead. So yeah, Canvas is more efficient in this case. It's possible, yeah, for sure. If you just like asking for a browser to get the bytes directly from server, you can just get the bytes. In the same manner, you can just download the image as a bytes, right? You can just there is a BMP format, so you can just get image unencoded. You can download it from server like using fetch, and then it's very easy decoding from the like raw image directly from server side. Yeah, sure.
Is it possible somehow to stream the data?
Yeah, sure. Yeah, sure.
HTML,
That is true.
audio, video elements straight to
Yes.
processing,
Yes.
some reverb, and then
Yes, you can do that. So basically, in the whole audio context thing, I know that I only showed the thing that just loads the whole audio file, decodes that, but there is create media element source, which is work as chunks. So basically, you download a specific chunk. It works totally as the same thing. You just download a specific chunk, and you apply a chunk, and you just modify a chunk, and then you can store it back into the actual audio file. Basically, it's I don't know. I thought that I included it, but apparently no, right? So yeah, you can for sure stream it. You won't like to download the 1 hour long podcast from the JavaScript memory. I insist you don't need to do that. Yeah, sure.
So, since you're only writing code in Rust, you can run portions of the logic in, let's say, lambda functions, for example. What's the benefit? I still don't understand what's the benefit for doing it in WebAssembly versus running those portions on.
So yeah, in fact, so yeah, as I said, so the framework fframes is pure Rust. We're rendering everything in Rust as a release mode. And in dev mode, you just want to have a code. You have your NeoVim or your VS Code here, and you have your browser here, and you type code, and you can see that it's changed here. But in order to do that, you need to somehow load all of the information in the browser. You can do that probably through the desktop app, but desktop app doesn't have that debug tools for SVG as browser have. So basically, I just faced this problem, and I tried to, as much as possible, bypass the limitation of the browser and bypass and make it as fast as possible to load the media files to make your preview looks like. So basically, as I said, as I showed in one image, in one video, so you just save it and it just immediately appears on the screen, and it works pretty decently right now. Yeah, sure.
UI, what's the UI? The one for like front and stuff.
Sorry, what? UI on
UI, exactly. The UX.
UX of so basically it is yeah, so it is a framework for developers. So you just write in your code, right? It's just like a file system base. So you just like have your file system. You have a bunch of audio. You have a bunch of media files in your file system. Then you just start in the server, and it just appears on the screen. And when you change the media file, you also get a propagation and reload. I think any more questions, right? Oh gosh.